So this week I read section 9 and I completed a few problems, the tail end, 21 problems. I don't know, maybe that's not a few, for section 8. So now I've completed all of section 8. There were 3 proofs. I'm up to 258 proofs, August 5th, 2025. Total of 563 problems so far, which is 33.4% of the 1,688 problems in Gallian. So section 8 was a happy section. Section 7 was a little difficult, as I mentioned before. Just a few rules in the section 7 problems that were not as easy for me to get into. In the case of section 8, it really was a more calculational and, to me, more straightforward, and to me also better laid out. That's just my opinion. So, and I've already mentioned section 8 multiple times. So this is really the very tail end of the chapters in section 8. And then section 9 is the kind of like the partner of section 8. In section 8, you take 2 groups and you make a bigger group. In section 9, you take that bigger group and you break it up into smaller subgroups. And they all have to be normal. That's just the rule for making up this, breaking up this pie. And the reason you do that is so you can have the external direct product and the internal direct product to be isomorphic. That's the whole business here. And one little thing that I think is I found really important, this example 3 was very useful, is that it's not like you have to set up equalities where the elements are exactly the same, as long as they end up being in the group that is the normal group. So, for example, here you're saying that the alternating group A sub n of even permutations is a normal subgroup of S of n, but then when you do 1, 2, and 1, 2, 3, they're not commutative. It's really 1, 2, 1, 2, 3 is 1, 3, 2, 1, 2. But then 1, 3, 2 is also in A sub n. That's a very important distinction, that it's not really like a very simple abelian thing. You could have them be different. You could have AH equals, you could have HA equals AH double prime, or AH is equal to H prime A. That's really important in this section. So laying out all the factor groups. Of course, it helps a lot to have a little bit of number theory, understanding of number theory, and then just lay out how you're actually chopping off a bunch of elements from the group, from, say, G. When you do the factor group, you're just chopping off all these elements. So, for example, here is a good example. So G is Z18, but H is the generator of 6, which is a 3-element group 0, 6, and 12. And so when you chop off H from G of H, you really, all the cosets are mod 6 now. They're not mod 18. And this very interesting way to reconstitute the table for D4 as factor groups. And so each little block, it's its own element in the factor group. All very interesting. Then an isomorphism theorem. And then, of course, talking about the internal direct products with diagrams, which really helps. So you can find subgroups within G, H, and K, and they only do intersection on the identity element of all 3 sets, of course, of all 3 groups. Whereas in the case of the direct product, you're just doing a direct product with anything. And there's the isomorphism setup between the initial internal direct product and the external direct product. And then groups of order p square. Now, one thing that's going to happen at some point is, this is going to be interesting for how I do this book, is once I finish the groups proper section, because this book was designed for a 1-semester course, it has a bunch of added chapters that don't stop the flow. But it's got a bunch of really good chapters on group theory, and they're really just group theory that begin with the silo or silo. I don't know. Somebody help me pronounce it. I'm going to pronounce it silo theorems. That's the way that I would normally pronounce it if nobody had helped me. And so what I'm going to do is do 9, 10, and 11. And then I'm going to jump to 24 and do 24 all the way down to 30. Yeah, to 30. And then 31, which is Introduction to Algebraic Coding Theory, requires a fields section. So that's the way I'm going to do it. Yeah. And then finally, some examples. And I've already started working on the problems. That's the book. Took a little longer than I should have, perhaps, because I went on that tangent of my future planning for this book. Yeah. So these problems were, as I mentioned the last time, super straightforward. I was very happy that I would figure out the LCM and the orders and all the combinations. And sure enough, I checked the answer and I would get it right. I would get it right. That felt really good. Yeah, I just kept getting things right. Except every now and then. Here, I made a mistake because when you break up these U groups of the factor of the total n, you have to make sure that you don't have that the greatest common denominator is 1. So the GCD of 125 and whatever is left is 1. Whereas if I do 200, the GCD of 205 is actually 5. It's not 1. So that was my mistake. Yeah, I made another little mistake like that here. But then in the RSA problems, I believe, I don't know, maybe it's one of these, maybe I'm a crank after all, but I believe that the answer in the exercise book is incorrect because you set up the block and it's 1812, which is really R is 18 and then L is 12. And then you do the calculations and the numbers are exactly the same as in the book, except for the actual block that you're sending. And the answer in the exercise book said step 3 fails. E is relatively prime to M. Well, it is. And if you set it up, and I actually did decode the message as well. So I don't know. Yeah, that kind of tripped me up. Okay, and then here's just a reading. But again, it's just the same as what I showed, except that I always like to fully work out all the examples. Yeah, which sometimes are not worked out in the book. Yeah, so actually I didn't just write this down from the book. I actually worked it out, every single example, every single block, one by one. Same here. Trying to draw diagrams. Example 15, I couldn't draw a good diagram to save my life. So when I come back with the problems, hopefully that will help me. Because, let's read it and you'll see how tricky this is. So H is the normal subgroup of G, and K bar is a subgroup of the factor group GH. Then the set K has the union of all the elements in the cosets of H in K bar. So I couldn't really, it's like, where do I put all these things? I don't know. This is a comeback when I work through more problems. Definitely a comeback. And then here in theorem 9.5, Gallian just casually says, the order of x is equal m and m is equal to qn and q prime, then x to the n, the order of x to the n is q. That is actually exercise 351. When you make the right substitutions, there was an exercise already in the book for that, way back in section 3. I like that. I like those callbacks. And then also in the case of example 18, I also worked it out. So when Gallian says, well, S3 is not cyclic, I took all the terms of S3. Sure enough, the largest are order 3 and S3 is order 6. And then when he says K is not normal, I went through it and I believe I got it right, explained right, that K is not normal because 1, 2, 1, 3 is equal to 1, 3, 2, but none of the other element products give you 1, 3, 2. I could be wrong, but I think that's the answer. And then just continue reading and finish reading section 9.